Hello, student. I am Pavitra. Thanks for joining Pavitra Chemistry. Let's start the class. Before starting, I am remembering you about the last class. In the last class, I introduced about the definition of science. Next, classification of science. Next, I already discussed about the definition of chemistry and different branches of chemistry. I also discussed about the importance of chemistry in daily life. Now it is time for moving the next content of Unit 1, some basic concept of chemistry. Before going to the topic, I want to ask some questions regarding about the next content. Can you define the definition of matter? What are the example of matter? What is solid? Can you give the example of solid? What is a liquid? Tell me, milk is a liquid substance or not? Next, can you define the definition of gas? Can you give the example of different gases? There are different type of question will come your mind when you want to know about what is matter and its classification. Let's go to the topic. What is matter? Matter means that is your in ODI it is said to be padartha. You know very well about the universe. Universe in Odia meaning universe means Vishwa. Look at that here two things are given. One is your matter, another is your energy. Energy means Shakti. Here one word is given universe. This sentence says that universe is made of two fundamental components. One is the matter, another is the energy. Before going to the definition of matter, I want to speak something. Suppose take an example. This is the said to be duster. This is your said to be duster. If you will think about this, it is said to be a matter because according to the definition of matter, matter must have some mass and need some space to occupy. One is what? The mass. One what is your that is your mass. Another is your what is now need some space to keep. Suppose I want to say that for keeping the duster on a table, we need some space. Similarly, uh, we need some space to keep the duster at any place. That means duster needs some space. If you will weight the weight of the duster, obviously the weight can be found that the weight must maybe 10 to 20 gram. The weight of the duster may be 10 to 20 gram. You know very well in your high school career difference between weight and mass. Difference between weight and mass. Weight means ozono. Next mass means your vastutva. There is a relationship between weight and mass. That is your W is equal to mg. You can say that your G means gravitational force. Gravitational force means madhyakarshana bala. Suppose if you will know the you find that the weight of the duster is your 10 to 20 gram. Then after dividing the value of G value is your 9.8. What is the G value? 9.8 meter per second square. Meter per second square. This is the G value. If you will divide the weight by the value of G 9.8, you can able to find the mass of the duster. From this discussion, it is seen that duster have particular mass and it needs some space. That means your duster is said to be a matter. Next, you can also think about the other example of matter. Here, another example is given, that is your stone. Stone have also fixed amount of mass, fixed amount of weight. Then you can divide the weight by the value 9.8, that is your gravitational force. You can easily find out the mass of the stone, and it also needs some space to occupy. Similarly, you can think that bricks, it have also some mass and need some space to occupy. Like gold, ice, these are the examples of matter. Matter is we can define matter. What is matter? Matter is anything that has mass and occupy some space. That is your said to be matter. Tell me, is crying is a matter? No, crying is not a matter because it have no mass and it does not need to occupy some space. If you will, if someone will cry, then a matter will issue. No, you do not think about that matter. That matter in ODI it is said to be Vishaya Vastu. No, this is not here. I am talking about the matter means Vastu. It related to the chemistry. Don't think about the other word matter. Here I want to say that whether crying is a matter or not. No, crying is not a matter because it do not have any mass and do not need any space to occupy. Similarly, can you say that happy is a matter or not? No, happy is not a matter because it do not need any space to occupy, and it have no mass. Similarly, you can think about laughing, other emotions, and other activities. Uh, these are not said to be matter. Matter must be anything which must have some mass and need some space to occupy. This is all about the definition of matter. Next, I will move to the classification of matter. What are the different types of matter? Matter can be classified into two different way. One is the physical classification. Next is the chemical classification. First is the physical classification, second is the chemical classification. Before going to the chemical classification, I want to say that, can you say that how many states? Don't think about the state means Rajya, state means here Avastha. How many states of a matter? There are generally three states of matter. One is the solid, another is your liquid, another is your gas. Suppose if someone asks you what is the state of ice, then obviously you can say that the ice is present in the solid state. If you will increase the temperature, then what will happen? Its state will change. That means it converted into water. If you will increase the temperature of water, then what will happen? It converted into steam. That means same substance, that is your ice converted into water converted into gas. These are generally depends upon the condition of temperature and pressure. If will give more pressure to the steam, then it converted into liquid. That means we can say that the physical state of a matter will change depending upon two things. One is your temperature, another is your pressure. By increasing or decreasing the pressure, we can convert the one matter in different state. That means you can change the state of a matter. So depending upon the physical state, Under ordinary condition of temperature and pressure, matter can be classified into three types. One is your solid, second is the liquid, third is your gas. Then can you say that what is solid and what is liquid, what is gas, and what are the examples of solid and what are the example of liquid and what are the example of gas? Let me discuss the definition. Remember two important things. One is your shape, another is your volume. So first is your shape, next is your volume. Shape means you can say that what is the meaning of shape, that is your akara. Volume means ayatana. If any substance which having definite shape and definite volume, that is called solid substance, and the examples are brick, wood, gold, stone. Similarly, if you will think about the liquid must have definite volume, but it do not have definite shape. Examples of liquids are water, milk, oil, alcohol. Like that you can think about gas having no definite volume and definite shape. The examples are nitrogen, hydrogen, oxygen, carbon dioxide, carbon monoxide. These are said to be gas. Let's discuss about the different types of matter depending upon the physical condition. I can explain more about this. Look at that. If you think about duster having definite shape. That is your, you can say that the shape of duster is your rectangular cubate. Uh, it can, the shape of duster cannot be changed by applying temperature, pressure. That means by increasing temperature, by decreasing temperature, or by increasing the pressure, or by decreasing the pressure. The shape always remain always constant. It does not changes. Like that, if you will think about the volume of duster, the volume of duster remain aroundly 600 cm3. uh, its volume always constant. By changing the temperature and pressure, the volume does not changes. The volume of the duster remain constant. Suppose if I want to give some times to change the volume of duster, it cannot be possible. Or the that means from the discussion, it is clear that duster is said to be an solid because it have definite shape and volume. Similarly, you can say that stone also having a definite shape and definite volume. So here stone is also called solid. Like that, you can think about bricks. Bricks also having definite shape and definite volume. So here bricks is said to be an solid. Like that, you can think about gold. Gold is also a solid because gold having definite volume and definite shape. Like that, you can think about ice. Next, I will move to the examples of liquids. Here the water picture. Here a picture is given in which water is present in the beaker. If I want to say that is the volume of water will change by taking in another container. Suppose here the volume of water is your 100 ml. Suppose I want to change this water into the packet. Is the volume of the water will change? No, there is no change of the volume of water. The volume of water here is also 100 ml. Suppose I want to change this water into the bottles. Here also the volume of water is your 100 ml. The volume remain constant. But if you if I want to say here what is the shape of water, then you can say that the shape of water depends upon the shape of beakers. Like that, you can think about the shape of water here. You can say that the shape of water depends upon the packet. Like that, you can think about the shape of water in the bottle. You can also say that the shape depends upon the bottle. That means from this discussion, it is clear that water have definite volume, but do not have definite shape. That means liquid have definite volume, but they do not have definite shape. So here water can consider as a liquid. Like that, you can think about milk. Milk do not have definite shape, but it have definite volume. It may be present in the packet. It may be present in any other container. The volume remain constant, but the shape may be changes. The shape changes. Similarly, you can take another example of liquid, that is your oil. Here, oil having definite volume, but do not have definite shape. Similarly, you can think about the solution of potassium permanganate. Potassium permanganate having also definite volume, but do not have definite shape. The shape depends upon the container in which it will present, that decide the shape. Next, I will move to the examples of different gases. Here, helium gases is present. Here, helium gas is present in the balloon. If I want to say that what is the shape of helium, then you can say that the shape depends upon the balloons. Suppose I will pressurize the gas into the balloon. No doubt, more amount of gas will present in the balloons. Suppose at particular pressure, 1 liter of gas is 500 500 cm of gas is present in the balloon. Suppose I want to pressurize and more amount of gas will enter into the balloon, then the gas is present. Then in the balloon, gas will maybe must be present. You can keep the gas into the balloon, but there is an increasing of pressure. That means by increasing and decreasing, we can change the volume of the gas. If I will increase the gas pressure, then the volume will decrease. Like that, if you will decrease the pressure, the gas will expand, and as a result, the volume will increase. Similarly, you can think about the temperature. If you will increase the temperature, then the gas having more kinetic energy, and it will expand, and volume will automatically increases. Like that, you if you will decrease the temperature, then the gases are nearer to each other, and the volume will reduce. Here, gas LPG gas is present in a cylinder. Shape is also depend upon the cylinder. Here, the volume you can change by applying pressure. By applying more pressure, you can increase the container capacity to keep more gas. Here, nitrogen gas is shown. Here also, the volume and shape will change. Next, the gas is present in the cycle tube. Here, oxygen gas is present. Carbon dioxide gas is present. These are the examples of gaseous substance which do not have definite shape and definite volume. Finally, I concluded that solid have definite shape and volume. Liquid have only definite volume, but do not have definite shape. Similarly, gas do not have definite shape and volume. This is all about the classification of physical classification of matter. Next, I will move to the chemical classification. Chemical, according to the chemical classification, matter can be classified into two types. One is the pure substance, another is the mixture. Pure substance in ODI is said to be Shuddha Padartha. Mixture means a Mishrana. Suppose take an example of pure substance. Suppose I want to take an example that is your water. Water is said to be a pure substance or mixture. You can decide whether water is a pure substance or mixture. Remember always in chemistry it is highly necessary. You always think positively. Or you don't think about the negative terms because there is no water present here without impurities. Every water, evenly distilled water or filtered water, must have also impurities. So always think positively. Suppose a question will ask by someone, or tell me water is a mixture or pure substance. You think about the positively way. There is no impurities present. So particularly if someone mentioned what is whether muddy water is a pure substance or mixture, then you think about that it is belongs to mixture. But always think positively. Similarly, you can think about gold. Gold is a pure substance, but remember, without impurities, you can unable to make any ornament by using the pure gold. There must be some impurities present in the gold. As a result, you can able to prepare the ornaments. So always think positively. Suppose a question will ask, gold is a pure substance or mixture, then you can say that gold is a pure substance. Be always think positively and explain. Now let's move an example. One is the water, another is your. Suppose I want to say another example is your sugar solution. First, I will say about water. Take example that is your water, another is your sugar solution. You can take sugar solution and another is your water. If I want to say that water belongs to a pure substance or mixture, or another question, sugar belongs to a pure substance or mixture. Suppose I want to say that how many components are present in water. Suppose always remember one important point. When you will break a substance, you will get different molecules. Similarly, if you will break the molecules, you will find atoms. Similarly, if you will again break the atom, you can find out the subatoms. Suppose I want to give 1 liter of water. Then I suppose I want to ask a question. What are the number of components present in the water? You must start there are one type of component, that is your water molecules. Similarly, suppose I want to ask about the sugar solution. For preparing the sugar solution, we generally need water and sugar. That means here you can say that sugar solution is made by two components. Similarly, suppose I will add lemon juice in the sugar solution, then the number of component changes to 3. That means we know that water generally belongs to the pure substance and sugar belongs to the mixture. Here you can say that pure substance is made by one component, but if you will think about the mixture, you can say that mixture is made by two or more components. Two or more components. More components, look at that. In case of sugar, two components are present. In case of sugar solution, two components are present. One is the water, another is the sugar. But when I will add the lemon juice in the sugar solution, that is your sarbat, then it is made by three components. So mixture must be made by two or more component. Pure substance made by only one type of components. Next, you can think about other terms. That is, suppose I want to say about the physical properties and chemical properties. Next, explain about the physical and chemical property. Water have a physical property that it helps to stop the burning. This is one type of physical properties. Similarly, it have a tendency to dissolve on the salt. It can react. It can convert the sodium chloride salt into Na plus ion and Cl minus. Water must have definite chemical property and physical properties. But if we will think about the sugar solution, what will happen? It do not have definite physical and chemical property. The physical and chemical property depends upon the amount of sugar. If we will increase the amount of sugar in the sugar solution, then there is a change of taste. That means the taste will increase. If we will increase the sugar amount in the sugar solution, the sugar particles, the concentration of the sugar particle will increase, and accordingly, the reaction will decrease or increase. That means I want to say that mixture do not have a definite physical and chemical property. Similarly, I will explain other terms, that is your composition. Suppose I want to explain about the composition. Suppose I will think about water. What is the composition of water? Water made by two things. One is your hydrogen atom. Suppose I want to take a water molecule. Water molecule made by two type of atom. One is your hydrogen atom, another is your oxygen atom. Number of hydrogen atom is your 2, oxygen is your 1. That means if I will find out the atomic ratio in atom, then I can find out 2 is to 1. That means 2 hydrogen, 1 oxygen atom. Similarly, if I will find out the mass ratio, then you can say 2 divide by atomic mass of oxygen is your what? 16. That means you can say that the mass ratio in water is your 2 divided by 16. That means you can divide, you can find 1 is to 8. Look at that. The mass ratio for the preparation of water is your 1 is to 8, and in number it is your 2 is to 1. Suppose I will increase one oxygen atom. That means here the number ratio in is your 2 is to 2, and the mass ratio must changes. That is your 1 is to 32. Sorry, 2. Uh, 2 is to 32 means 1 is to 16. The here what happens, if you will increase one oxygen atom, then the mass ratio changes, and also the atomic number ratio in terms of number of atom also changes. But remember one important point: by increasing the oxygen number, you unable to find about water. You the formed substance is not said to be in water. It is just said to be hydrogen peroxide. That means for the preparation of water molecule, you must take two hydrogen atom, one oxygen atom. If you will change whether oxygen atom or hydrogen atom, you are unable to find the water molecule. You can find other molecule, but you cannot find the water molecules. That means here we can say that water molecule must have definite composition. Suppose I will explain about the sugar solution. For the making of sugar solution, someone can take suppose 100 grams of sugar and 1 liter of water. It can possible. Similarly, if someone takes 200 gram of sugar and 2 liter of water, this is said to be also sugar solution. That means I want to say that by changing the amount of sugar or water, you can able to find about the sugar solution. However, they are different in their test. They are different in their concentration, but the solution must be said to be what sugar solution. That means the sugar solution having no definite composition. That means from this discussion, we can conclude that pure substance having definite composition and definite physical property and chemical property. You can say that pure substance. Then what will be the definition of pure substance? Pure substance is a one type of matter which is made by only one type of component and having definite physical and chemical properties and having definite composition. This is the definition of pure substance. On the other hand, if you will think about the mixture, I will explain about details of mixture just after few times. After complete details about the pure substance, I will explain about details of the mixture. But from the example, I have given some idea about the definition of mixture. Obviously, mixture do not have one component. It have variation in their physical and chemical property. It do not have definite composition. You can change the composition. Finally, again I will repeat what is pure substance. Pure substance is a matter which is made by only one component with a definite physical and chemical properties and having definite composition. This is the definition of pure substance. Next, I will move to the classification of pure substance. What are the classification of pure substance? Pure substance classified into two types. One is your elements, another is your compound. Elements means you know that elements means molecule, compound means jaugika. You already know about the definition of element and compound in your high school level. Element is the simplest form of a pure matter. Simplest form of a pure matter is your element. It is made by only one kind of atom. One kind of atom means, suppose I will take an example of element, that is your iron. Take 1 gram of iron. This is said to be a substance. If I will break the iron, then what will happen? Then I will find about the iron molecules. Then we can find about the iron atoms. That means iron is said to be an element because the simplest form of iron is made by only one kind of atom, that is your iron atom. Suppose I want to break the iron atom, then it cannot be break. If it will break, then it is not said to be an iron. The iron atom can convert it into subatomic particle, electron, proton, neutron. At that time, you cannot say that this is your said to be iron. You cannot break again into the simpler matter. You cannot build the iron elements from simpler matter. That means it cannot build or break. It is the simplest form of pure matter. It is made by only one kind of atom. Take examples. Here, the example of hydrogen atom is given. If I will think about the hydrogen substance, suppose I will give 1 ml of hydrogen gas. You can say that when you will want to break, then will find out the hydrogen molecule. Some hydrogen molecules are present. If you want to break again the hydrogen molecule, it will give hydrogen atom. Only one kind of atom is present, and it is the simplest form of the pure matter, and it cannot decompose into simpler matter or built from simpler matter. Here we can say that hydrogen is an element. Similarly, if you will think about helium, boron, carbon, all are said to be element. Suppose I want to give water. Can you say that water is a element or compound? No, it cannot be said to be an element because there are two types of atom. One is your hydrogen atom, another is your oxygen atom. Totally three number of atoms for form one water molecule, but there are two types of atom. Total number is your three. Type of atom is your two. That means it is not said to be an element because it is made by more than one kind of atom. Suppose I want to break, then it gives two type of atom: hydrogen, oxygen, three hydrogen atom, three atom, two type of atom, but the number of atom is 3. That means it break into the simplest form, that is your hydrogen atom and oxygen atom. It can build, that is your, when I will combine two hydrogen atom, one oxygen atom, then it forms a substance. That means it can build and break. Here, so we cannot say that water is not a element. It belongs to a compound. Let me classify about the atoms. Sorry, about element. What is a what are the different types of element? You know about the periodic table. In Odia, it is said to be Pojja Sarani. There are many numbers of elements present. There are three types of elements are present. One is the metal, another is a non-metal, next is your metalloid. Metal means dhatu, non-metal means adhatu, metalloids means that is your said to be upadhatu. Suppose I want to give some examples of metal. Here, copper, silver, gold. Give examples of non-metals. Here, the example of non-metals are present. That is your helium, carbon, oxygen. Examples of metalloids are boron, silicon, arsenic, antimony, tellurium, polonium, germanium. Let me discuss what is metal, what is non-metal, and metalloid. Suppose I want to take an example of iron metal. Here I have given a picture that is your cast iron. Suppose I will rob the cast iron, then what will happen? Its brightness will increase. That means I can say that iron having the property like luster. By robbing, we can increase the brightness. We can see there is an increase of brightness by robbing. Iron is hard. It have a hardness, that is your kothinanta. Brightness in is said to be luster. Iron having luster property, hardness property, ductility, namyata. That means when we will stretch the iron rod, it convert it into wire. Iron having also malleability, that is your pneumonia. That means when you will hammer the iron, cast iron, then it converted into sheet. Here you can say main point. When we will pass the electricity through cast iron by any metal, then the metal can able to conduct electricity. Another thing, when you will hit one end of the iron, then heat will transfer from one end to other end. That means I can say that what is metal? Metal must be an element. Yes, metal must be an element, but it have the properties like luster, hardness, ductility, malleability. These are the special property of the metal, and it have able to conduct heat and electricity. That type of element are said to be metal. Again, I will repeat: metal is the element which are able to conduct heat and electricity and having different property like luster, hardness, ductility, malleability. Here, there are different examples of metals are given. This is your cast iron, this is your zinc, this is your aluminum, titanium, tin, copper, lead, gold, nickel, silver. There are, if you will say that in periodic table, 80% of the elements are metals. More than 80% elements, total elements are metal. Like that, if you will think about the non-metal. Take example of carbon. If someone rubbing the carbon on table, can you say that there is an increase in the brightness of the carbon? There is shining in the carbon? No, there cannot. The carbon cannot be shining by rubbing. That means carbon must have non-luster property. If you will press carbon, then it easily break. That means there is a property found in non-metal. It can easily break. That is said to be brittle. Brittle means in Odia it is said to be bhangurata. Clear? Next, if you will pass current through carbon, except remember an exceptional is present. Exceptional case is present. That is your graphite. In case of graphite, electrical current can pass from one end to other. So out keep out this from your topic. Uh, Carbon, except graphite, carbon unable to conduct electricity and heat. That means it is a poor conductor. Similarly, think about iodine, phosphorus, sulfur, selenium. All are unable to conduct electricity and heat. Here the diagrams are present. This is a carbon. Here helium gas I have taken in the container. Fluorine gas, sulfur, iodine, oxygen, phosphorus. These are the non-metal examples. They have do not have no, luster property. They are simply non-luster. They are brittle in nature. They are unable to conduct heat and electricity. However, there are few exceptional cases are found. For example, in case of graphite able to conduct heat and electricity. Next, I will move about the metalloid. Metalloids are the elements which having both the characteristics of metal and non-metal. That means it can, in some case, by applying some condition, the metalloid can conduct heat and electricity. But it may have some luxury property or not. It is maybe brittle in nature. For example, if you think about boron, silicon, arsenic, antimony, tellurium, polonium, and germanium, these elements can able to conduct heat and electricity by by changing the property like pressure, temperature, like that. I can say funny things. How can you know? Simply, you can describe, you can identify in your daily life whether it is metal or not. Don't think about it serious. I am just joking with you, all of you. If you enter the, suppose I will give a substance in rod shape. Can you easily detect whether it is metal, non-metal, metalloid? If you put the rod into the plug, that is your electrical um, connection, you will give electrical connection, it will catch, it will spark you. That means yeah, this is your said to be metal. If you, it will not catch you, that is said to be non-metal. That means simply you can, providing the electrical current, you can able to find whether it is a metal or non-metals. Metalloids are difficult to identify whether it is metal or metalloid or non-metal. Metalloids, as compared to metal and non-metal, it is very difficult to identify which are said to be metalloid, because under certain condition it act both metal and non-metal character. Next, I will move about the compound, that is your Jaugika. Remember an example, take an example. Suppose I want to say that water. I will take an example of compound, that is your water. If I want to say that water is made by two elements. I am correct. I am wrong or correct? Yes, I am. I am correct, because one is your hydrogen element, another is your oxygen element. Next, if I will say about the composition. Already I discussed water is made by two hydrogen atom and one oxygen atom. If I want to say about the ratio in number, then you can set that 2 is to 1. Suppose if I want to say about the mass ratio, then I can write here 1 is to 8. That means water having definite proportion, and it is made by, here you can say that two element. For example, I will take another examples, that is your suppose H2SO4. H2, in H2SO4, three type of atom are present. One is the hydrogen, another is the sulfur, next is the oxygen. But the number of atom, total number of atom is your what? 4 plus 1 plus 2, that is your 7. 7 total number of atom in a sulfuric acid, that is your H2SO4, is your 7, but type of atom is your 3. Here in this case, the number of elements, you can say that 3. One is your hydrogen, sulfur, another is your oxygen. Here H2SO4 is said to be a compound because it is made by two or more elements, and the elements must combine with each other in a definite proportion. So I can define the definition of compound. Compounds are the pure substance that is formed by the union of two or more element in a definite proportion. The proportion must be a mass. You cannot say about the proportion. The proportion means ratio. In number, must be mass. Take different examples of compounds. These are the different metalloids. This is a boron, silicon, arsenic, antimony, tellurium, that is a polonium, germanium. Let's discuss about the compound. Here, suppose I want to say about the rock salt, NaCl. Here, I can say that rock salt. Rock salt is made by two element. One is your sodium, another is your chlorine. So here you can say that rock salt, and it is also made by specific proportion. So here you can say that rock salt is an compound. Like that, you can think that washing soda also compound, marble compound, gypsum, baking soda, limestone, quartz, sodium nitrate, glucose, fructose, fat, oil, wax, protein, vitamin, all are said to be compound because it is made by two or more element and in a definite proportion. Can you define? Can you classify how many types of compound? Suppose if I want to say that about NaCl. Can you say that NaCl is prepared from any living organism? No, NaCl cannot prepare from the any living organism. It is prepared from the rock salt. That is minerals. It is found in. It is prepared by using the salty waters. That is your sea waters. So NaCl cannot found from the any living organism. Similarly, if I'll ask you about washing soda also not found from the living organism. Marble not found in the living organism. Gypsum cannot found in the living organism. Like that, you can think about baking soda, lime, quartz, sodium nitrate. All are not found from the living organism. But if I want to say about glucose, fructose, or next fat, oil, wax, protein, next is your vitamin, then these substances are found from the living organism. From the discussion, you can think that there are two types of compound. Must there must be two types of compound. One is your one type of compound generally found from the living organism, and other type of compound found from the non-living organisms. Non-living organism means you can think about the minerals, rock salt, like that. uh, the compound which are found from the living organism, that is said to be organic compound. Organic compound means jaiva padartha. Next, inorganic compounds means ajaiva padartha. There are two types of compound. One is your organic compound, another is your inorganic compound. Inorganic organic compounds means generally found from the living organism. Inorganic compounds generally found from the non-living sources like minerals, rocks. These. Here, tell me, glucose. Glucose is a organic compound or inorganic compound. Glucose generally related to carbohydrates. Carbohydrates found from the found in the different fruits, vegetables. Yeah, and the vegetables are found from the plant. Plant is a living substance, as a living organisms. Similarly, if you will think about fructose, it is also related to the living organism. Oil, fat, wax, protein, vitamin, all are belongs to the living organisms. So they are said to be organic compounds. If you will think about sodium nitrate, not it is not found from the living organism. Similarly, quartz, lime, baking soda, gypsum, marbles, washing soda, rock salt. These are not these compounds do not belong to the living organisms. These are said to be inorganic compounds. So finally, I can conclude that compound can be classified into two types. One is your inorganic compounds, another is your organic compounds. The list of inorganic compound is here given here. Next, the list of organic compound is given here. These are the inorganic compound, and these are said to be the organic compounds. Next, this is all about the compound classification. Next, I will move to the mixture. I already given an example, that is your sugar solution with lemon juice. These are the mixture. They do not have a definite composition. I already told you they are made by two or more components. I already discussed about. Look at that. There are some examples which are belongs to mixer bronze. Next is your salt solution, sugar solution, vinegar, tea, coffee, petrol, soft drinks. So that is your cold drinks. Next, you can think about mixture of oil and water, mixture of water and sand, mixture of ice and water. These are the examples of mixture. In all the case, you can say that it is made by two or more element or compound. Remember one important point: mixture can be formed by using elements only, or by using compounds only, or element and compounds. That means you can say that the matter that is made by two or more element or compound in any proportion. You can take any proportion, 1 is to 2, 2 is to 1, as your choice you can take. You can able to find about the mixture substance. So again I will repeat the definition. The matter that is made by two or more element or compound in any proportion by mass is called mixture. In mixture, the compound retain their identity. A very important point. Suppose I will think about the one example, that is suppose I want to take water. If I will think about two example, I will give two example. Suppose I want to give one example is your water. Another example, suppose I want to take water. Another is your sugar solution. Take sugar solution and water. If I want to say that water is made by two atoms, that is your hydrogen and oxygen. Hydrogen, if you will think about hydrogen and oxygen, its properties is quietly different from the properties of water. Oxygen helps to burn, can burn, but water stop the boiling. Hydrogen, oxygen are related to the increase of the boiling of a substance or itself, burning of hydrogen gas. But if you think about the water, it stop. That means I want to say that the identity of hydrogen and oxygen cannot seen in the water substance. That means they loses their identity. When hydrogen and oxygen combine to form water, final water is formed. But in water, the water molecule does not show the properties of hydrogen and oxygen. Water molecules show another properties. But if you will think about the sugar solution is made by two components. One is the sugar, another is your water. If you will think about the sugar having sweet taste. In sugar solution, the sweetness is also present. The sugar do not loses its sweetness. It keep its sweetness also in the sugar solution. That means in case of compound, in case of pure substance, the elements loses their identity, but in case of mixture, the components do not loses their identity. This is the very important point. So here I can say that here I can say that in mixture the compound retain their identity, but in pure substance the components do not retain their identity. Mixture can be classified into two types. One is your homogeneous mixture, another is your heterogeneous mixture. Homogeneous mixture, remember one important point, completely depends upon the single phase of the system. Next is the heterogeneous mixture, completely depend upon the two or more phases. Here I can explain better in better way. Here one word is given, that is your homogeneous. Homogeneous. Homo means what? Same. Next word is your heterogeneous. Hetero means what? Different. If the mixture having same phase, that is your single phase, that is your said to be homogeneous. If a mixture are made by two or more phase, that is your said to be heterogeneous mixture. Let me discuss which is said to be homogeneous mixture and which is said to be heterogeneous mixture. Remember one important point. This is the important point. You can, by using this point, you can practically you can able to see, define or classify which is belongs to homogeneous mixture and which is belongs to heterogeneous mixture. The very few very important point, uh, if you want to see the component of homogeneous mixture, you cannot see, even by using powerful microscope you cannot see the component of component present in the homogeneous mixture. But if you will think about the components of heterogeneous mixture, in heterogeneous mixture, the components are can be easily seen with naked eye. By using naked eye, that means you can easily detect the components of heterogeneous mixture. This is very important point. The components of homogeneous mixture cannot be seen by using naked eye. That means it cannot be also seen by using powerful microscope. But if you think about heterogeneous, it can be easily seen. Another important point, homogeneous is made by single phase, heterogeneous is made by two or more phase. Let's discuss about the examples of homogeneous and heterogeneous mixture. Look at that. It is a mixture. It is the mixture is prepared by two component, oil and water. Look at that. There are no single phase. There are two phase. In the upper, you can detect that this is one phase, and the bottom, in the bottom phase, this is your water phase, this is your oil phase, and this is your said to be water phase. That means here two phases are present, and it completely belongs to heterogeneous mixture. Remember, if single phase, then it is said to be homogeneous. If different phase, it is said to be heterogeneous. Here two phases are present, so this is said to be an example of homogeneous, as an example of heterogeneous mixture. If you will say about the detection of the components, you can easily see that by using your naked eye. You can say that this is the oil and this is your water. So it is said to be one example of heterogeneous mixture. Next, this is a mixture of sand and water. Here also two phases are present. One is the water phase present at the top, and this is your sand phase, that is your second phase. Your two phases are present, and the components are easily seen by naked eye. So here you can say that mixture of water and sand is said to be a heterogeneous mixture. Next thing about this is your mixture of ice. Look at that. When you will increase the temperature of this mixture, then the ice will convert it into water, and it is said to be compound. But if in the water floats, there is a other phase. I can say here that this is your ice phase and this is your water phase. That means there are two phases, and the components are easily seen by naked eye. So this is said to be one type of mixture. It is not said to be a compound, and it completely belongs to the heterogeneous mixture. Like that, you can think about other examples. Simply, you can think about this is your petrol. This is also heterogeneous. Sorry. If you think about the examples of homogeneous mixture, look at that. This is your sugar solution. The components of sugar, the component that is your sugar cannot be seen by naked eye. Even if you use the microscope, then the components are not seen by using microscope. All the whole system, if you see the whole sugar solution, it will look like one patch. There is no separation. So you can see that one component, one phase is present, so it belongs to your homogeneous mixture. Like that, you think about the vinegar; it is also belongs to homogeneous mixture. Next, coffee, tea. This is your tea. Here is also you cannot see which particular tea, which particles are what. Here all this totally you can see in one single phase. That is your made by only one component. You cannot see even by using microscope. So it belongs to homogeneous mixture. Similarly, you think about coffee, petrol. Petrol is made by different type of hydrocarbon. You cannot see which hydrocarbon is what. You can see about the soft drinks, that is your cold drinks. These are also belongs to your homogeneous mixture. One important point. At last, I want to say one an important point. Look at that. Suppose I want to take a homogeneous mixture and heterogeneous mixture. This is your homogeneous mixture, that is your sugar plus water. Your sand plus water is present. Look at that. Here there is a uniform distribution of the sugar and water molecules. But here there is no uniform distribution between sugar and water and sand particles. In the bottom, the sand particles are more. In the top, water particles are present. Here, the sand particles present. Here, the sand. This is your water. But here, look at that. Sand, water. Sugar, water. The white mark, suppose I want to take water molecule, or the blue dots you can take as the sugar. White water, blue sugar. Look at that, they are arranged in a uniform manner. Here you cannot find such type of uniformity. Here the components are present in non-uniform manner. Due to the uniform manner, as a result, when you will drink the sugar solution, the taste is remain same up to the end of the the sugar solution, at the beginning and the last. during your when you drink the sugar solution, you feel the same taste. So this is due to the uniformity of the sugar and water particle distribution. But if you think about the sand water mixture, you can drink the water first, then at last you will drink the sand. So the important point is in case of homogeneous mixture, there is an uniformity distribution of the components, but in case of heterogeneous, you cannot find such type of uniformity. Homogeneous, there is a uniformness of the components. In heterogeneous, there is no uniform. This is all about the different types of mixture. Um, in the next class, I will discuss about the um, composition of matter and properties of matter. Thank you very much. Have a nice day. At last, I can say that. Sorry, at last, um, I can. I want to say something. You can download your class notes by visiting the website pavitrachemistry.in or pavitrachemistry.com or pavitrachemistry.org. You can easily download the class notes and prepare your notes. Thank you very much. Again, I will repeat, in the next class I will discuss about the composition of matter and properties of matter. Have a nice day.